From Spirax Sarco, we're going to run through a little bit about steam sterilisation and also how we're preparing for that journey to net zero. So we're going to go through a few of our new innovations around electrifying steam generation. We're going to be about a 30-minute presentation, then we'll have 10 minutes for Q&A at the end, so get your questions ready. So I'm Sean Spencer. I'm the Solution Delivery Manager for our new Sustainable Solutions, and I'm going to be presenting alongside Chris Yates, who's our Principal Product Manager. So Chris is going to be taking you through how we've tested our clean steam generator, a piece of equipment that we sell into healthcare that actually generates really high quality clean steam that you can use in your sterilizers, autoclaves, and those kind of things. And Chris is going to be talking about how we've validated that bit of technology. So who are we? Has anyone heard of Spirax Sarco, the steam business? Yeah, a few nods, that's good. So we're actually the blue company. You can see here, me and Chris both work for our steam sector of this quite large now, multi-billion-pound multinational. Over the last couple of years, we've made some really nice acquisitions into the electrical division. So we've armed ourselves with some really key businesses that are allowing us to bring electrical and steam generation together and allow us to decarbonize some of our solutions. So I'll be talking about those later in the presentation. So we've got what we call our Electric Thermal Solutions division, which you can see on the right-hand side here, that are helping us bring together our steam knowledge and our electrical solutions so we can decarbonize that steam generation. You can see the revenue streams here, split 54% and 16%. So our current steam business dominates our group. And we're anticipating this is really going to grow electrically as we start to bring in those net zero solutions, electrifying, using renewable electricity generation. We also have Watson Marlow, our niche pumping business on the right-hand side there. You may have come across them in the hospital as well. A lot of very specific, good quality pumping, niche pumping products that they produce. So we've got quite a global spread now. We've got 146 operating companies, over 10,000 people globally, over 2,000 sales engineers. We really value that presence, being in with the customers, getting voice of customer, providing those end user solutions. 67 countries where we have a direct sales presence, so a sales office. We actually facilitate sales in a lot more countries than that. A lot of product lines, a very thick product catalogue because of the different niche things we get into. So as Chris will talk to you about the CSG later on, the products associated with that, there's probably 50 or 60 products in the CSG to enable that to perform as it does. And over 110,000 direct customers. As I mentioned previously, we really value that end-to-end customer interaction. So I'll hand over to Chris to take you through the steam stuff.
So, why is steam used in sterilisation? And we know we've got the HTM 0101, Part C, specifically about steam used in sterilisation. It references steam as being the preferred sterilant because of its sterilisation qualities. So, most importantly, the high temperature is crucial for destroying the microorganisms, including the bacterial spores and fungi. You can see the sterilisation temperatures there, 121, 124, and the whole time. There's other reasons as well why steam is used as a sterilant, is its penetration, because it's a gas, it allows it to get to all the different nooks and crannies on what's being sterilised. It's fast and efficient. It's non-toxic compared to some chemicals that can be used. It's versatile, so it's suitable for a range of different materials. It's reliable, tried and tested, and it's also cost-effective in the long run compared to alternative fluids. So, we know we've got HTM 0101 and we have EN 285 compliance, all governing what we do with steam in sterilisation. So what I've done here, it's very wordy, this slide, and apologies for that, but what I've done is I looked through this document and I've picked out the really poignant references that point to heat transfer and that really important heat that's transferred to sterilize the equipment. And there's things that come up like with the feed water to avoid scaling and corrosion, because that can create a barrier to heat transfer. Making sure we remove air from the chamber, because air again can be that barrier for heat and sterilization. Removing non-condensable gases. So we have an EN285 test for NCGs. The steam must be below 3.5%. So the gases in the steam can cause corrosion of instruments, but it can also collect as concentrated bubbles in the load to be a barrier to heat transfer. It talks about steam quality tests being carried out frequently, especially where there's different dynamic loads and demands on that throughout the hospital for steam, making sure that quality is always good before the sterilizers. Again, quality of steam and testing, avoiding accumulations of condensate and water, because that can also create that barrier to heat transfer. And avoiding wet steam, because that will be insufficient energy to the surface of the load to be sterilized. So hands up if you're aware of EN285 as a compliance for steam for sterilization. Yep. So I'll go on shortly to talk about a clean steam generator that we specifically designed and developed and test for sterilization to make sure it met those EN285 requirements.
We've already, 5 minutes in, we've mentioned steam quality quite a few times, right? But what actually is it? What is it when we say steam quality? So steam quality is our measure of how dry the steam is, how much of a gas it is, okay? Because at that pressure and that temperature, 2 bar, 133 degrees C, we can actually be fully liquid. We can be entirely water. This is when we talk about boiling water at 100 degrees. Water can be 100 degrees and fully liquid, okay? When we talk about quality, it's a measure of how much of that water has evaporated. In an ideal world, we want to be using steam that's 100% a gas, 100% dry. It doesn't carry any water droplets with it. It's not carrying any contamination. It's not damaging our equipment. And as Chris mentioned, it's maximum heat transfer. Because as soon as that gas meets a cold surface, it's condensing, and it's giving up all of its energy as it turns back to a liquid. So our mission, really, Spirax's mission, is to ensure that every bit of steam that's generated is 100% a gas, because it's going to be a most effective heat transfer medium. It also makes it really hard to monitor. So pressure and temperature, really easy to monitor. Pressure sensor, temperature sensor, really straightforward. But across this line that we're going to go through in a minute, across that transition from being a liquid to a gas, the pressure and temperature doesn't change. So how are we going to monitor it? We could have a pressure and temperature of 2 bar, 133 degrees C, be completely liquid. We could be 100% gas. We just don't know. So when Chris gets on to explain how we validated it, you'll see actually how complex that is and how important knowing the equipment that you're using is actually generating pure steam is very important. So let's put some numbers to this. This is a temperature enthalpy chart. So what we're looking at here is temperature of a steam. These gray lines coming down here give you a pressure. So on this line here, we're a constant temperature, a constant pressure. And this is our energy content that we call enthalpy. So that's how much energy does the steam have per kilogram. We want to be right up this end, because we can then transfer that energy back into the process when we condense the steam. So if we run through this, 2 bar, 133 degrees C, and our quality is 10%. It's pretty much entirely water. Our energy content is right down here, 600 kilojoules per kilogram. Okay, still quite a lot, but it's not as much as we could have. So let's stay at the same pressure and temperature. Let's make our steam better quality, so drier, less water content, more vapor. Well, we've now got over 1,500 kilojoules per kilogram. So for pumping the same mass of fluid down that pipe, we've got 3 times the energy content in the same pipe. Now let's go one better. Let's go up to 90% quality. We've got 2,500 kilojoules per kilogram. So 4 times our initial energy content in the same pipe. That's why steam quality is so important. So when this meets surgical instruments, when it meets packs in your sterilizer, we need to make sure we've got maximum heat transfer, because that's what's killing our bacteria. That's what's making sure we don't have wet packs. That's what's making sure we don't have to reprocess our equipment. So it's really hard to visualize. So our research department actually went away and videoed it, which is really nice of them, really, because it helps me massively putting this into your minds in terms of what does wet steam look like. So on the left-hand side here, this is 90% dryness. So I've been talking about 10 and 50. Steam at 10 and 50% quality, you just see water down the pipe. Here we are at 90, and you can see these water droplets carried in the steam. They're causing corrosion because they could have chemical in them. They're causing erosion because they're being dragged along at high velocity with the steam. They're colliding with equipment, with valves, with delicate instruments. So a lot of damage caused by these water droplets. And also the heat transfer is massively reduced. You can see on the right-hand side, that's 97.5% dryness. So with EN285, this is the kind of quality steam that we're aiming for. I've just talked through a few of the impacts of not having good quality steam, and really that's around, I know the previous presentation was all about optimizing how many loads you can get through, not missing those, not delaying surgery. This is ultimately the patient's care at the end of it. But what we see in the plant room side is reprocessing, wet packs, problems with sterilization. And ultimately, all that means is added time and cost in either reprocessing or actually finding the cause of this problem. And one thing that we want to get across today is the reason Chris has spent many hours of his life validating our technology is we can guarantee that good quality steam into the sterilizer. So we're narrowing down the options to where these problems are coming from.
The purpose of this slide is just, the reduced heat transfer, the poor steam quality, some of the quality issues that we understand you see around sterilization is visible in these images here. So some moisture left on packs. So these are failed sterilizer loads. And of course, this incurs additional time and cost. So this in the middle here is what we were tasked with designing and developing specifically for sterilization in the healthcare market. So I'm going to talk to you a bit about our test setup. So it was a multi-million-pound investment. This is our test facility, these images. So you can see here we have reverse osmosis feed water feeding into our clean steam generator. So this is, our objective here is to make sure that this generates steam for the sterilizer, meeting EN285 compliance all the time, regardless of the loads, how dynamic that system is. And unfortunately, we had to vent that steam to atmosphere. But on the outlet pipework, which would otherwise go to the sterilizers, we had an ability to continuously monitor the steam dryness and NCGs and superheat. And here you can see a control valve. And what this control valve could do is, depending on its opening position, is create a demand on this clean steam generator, which would simulate your sterilizers consuming that steam. So with a steam meter and these different control valve open positions, we could basically model different load scenarios on our clean steam generator. So we were able to measure the bulk dryness using temperature and pressure and back calculating from the enthalpy, which Sean showed you on the charts, to work out what that dryness would be. The limitation with that is with the pressures that we were working at going down to atmosphere, because it vents to atmosphere, we could, using the bulk dryness, which is after the control valve where it all mixed together, we were limited, we weren't able to measure below 96% dryness at certain pressures. So what we did is we did a second means of testing it with a pitot tube, and we put compressed air through an ejector, and it created a vacuum. And with that vacuum, a higher differential pressure, we were able to measure down to 94% steam quality. So, and then we also had our EN285 manual test capability as well. So we were intermittently testing that. So we had 3 different ways of testing our dryness. So we also had a model, an Excel table showing our steam flow rates and the time period across a sterilizer cycle. So it was around 50 minutes, and we had like a vacuum phase and steam pulses and, you know, the plateau phases and charging phases. And with our clean steam generator, we had a theoretical capacity of what it could generate in terms of steam volume. So what we were able to do is basically take that theoretical capacity, prove that we could always achieve EN285 dryness, non-condensable gases, and superheat. And then what we were able to do is divide, taking our maximum load, we were actually able to simulate multiple sterilizers all running at the same time, all press and go at the same time to create the worst case dynamic conditions. This slide zooms into 5 minutes. This is an 8-bar plant steam generating 3-bar clean steam. You can see here that these are the real spikes. So we were able to go up to 620 kilograms an hour, which was 3.29 sterilizers running at the same time. And you can see here that where we had the high spikes in steam demand, you can actually see the steam quality drop off. Can you see after the high demands? We were still able to stay within 95, which is this here, look. So we were able to prove that we were able to do that with our clean steam generators. But what it does really indicate is that that was with a high volume of steam, with reservoirs of steam in the pipework. If you would scale this down, I should imagine these drop-offs in steam quality would be much more exacerbated. This here, so we've talked about steam dryness and how we were able to prove that out with dynamic load conditions. We've also introduced a deaerator tower, which is a degasser. So this is how we achieve our non-condensable gases. So this is a picture of our patented technology. And you can see here that we had a thermocouple onto the test unit where we were able to measure the temperature of the water as the feed water cascaded through these different trays here. So we were able to test this across all the load conditions to prove that we were getting the adequate temperatures and contact time to remove the gas which would be vented off the top of this deaerator. This piece of equipment here is called an orbosphere, and one of the markers for non-condensable gases is dissolved oxygen. So we were able to continuously bleed our water from our clean steam generator and cool it and measure the amount of dissolved oxygen. So we were able to prove out that we could always deliver within 3.5% non-condensable gases. So, as I said, we had the capability to measure using the manual test kits as well, which is what is typically done in a hospital or sterilization environment. And we had some independent third party come in to do the validation testing of our equipment as well across like minimum and maximum loads and transient load conditions. And those certificates are available upon request.
What I'm going to show you now is how I stole some of Chris's work and used it to my advantage, because for the astute ones amongst you, you'll notice that this is Chris's patented deaerator tower that's sat in one of our new storage technologies. So having done all of that work, having proved out steam quality, done all of the work on the CSG, having all of the spreadsheets, the knowledge, the expertise built up, The next step was for me to go and steal all of that and then electrify one of these systems with all of that knowledge, with all of that expertise, with the support of Chris's team, and take us down the decarbonisation route. So develop a solution that can utilise electricity from a renewable source, from a green tariff, and start to decarbonise the steam generation. And we'll talk about why that's so important for us, why we're putting such a focus on it later on. A lot of it is around infrastructure retainment. It's around retaining this existing equipment that you all know how to use now, that the standard operating procedures are developed, people are trained in how to use it. What we want to do is sneak in and change the fuel from a fossil fuel to some renewable electricity. That's our kind of like golden vision. So this is the storage technology that we've developed at Spirax. We've called it steam battery. We tend to name things in a Ronseal way, so they are what they say on the tin. And this unit here is hidden up in the rafters there, so Chris couldn't take it back. And it's helped us really develop this technology really quickly with some really robust and validated analysis tools. We'll talk more about that on the later slides. We've also got what we've called an electrofit. This is an electrical retrofit of an existing gas boilers. I imagine the majority of the steam on the sites you guys are from is generated using natural gas, especially in the UK. So big assets, well maintained, big capital bits of kit, and all of the valve gear, pipe work associated with that is already in situ. It's already been invested in. So this solution that we've developed to take to market is basically a way of opening the doors, taking the gas burner out, throwing that away, putting electricity into the boiler with some elements, closing the doors again, and firing it up as an electric boiler. So everything else remains the same. There's a number of benefits, actually, to switching from gas to electric. We don't have any flames. We've got no explosion issues. We don't have to purge the boiler before we ignite it and after we've finished burning our gas. So from a safety perspective, okay, we introduced some other ones in the management of electricity, but they're pretty well regulated and understood. Increased efficiency. We don't have any losses through the stack. There's no exhaust as such from the boiler. And we have really precise control, which I'll cover in a second. We don't have the same kind of maintenance requirements from managing a burner, from cleaning tubes, from the scale up of the heat transfer area inside the boiler, so we can reduce the costs of that slightly too. It's a much cleaner operation on the site. We're not emitting any burnt fumes from the site, and in collaboration with the green tariff or local renewable generation, we can start to remove scope 1 and scope 2 from sites. We've got very precise temperature control on these systems. Because it's electrical, we've got thyristor control, which is millisecond response times in our power demand. We don't face the same issues with turn down as we would do on a gas burner, where we may be limited to a 10-to-1 ratio or whatever. We can go 1 to 100% of this capability. So really quick, really precise control. And with that control, we can control our costs. We can use off-peak tariffs if they're available. We can respond to intermittent renewables as well. So it gives us full flexibility on the system. If we can electrify an existing steam system that's already installed on a site, that's where we start to see real benefits. So if we can optimize a system to fit within an existing power supply, we don't need any new cabling, any new substations, any upgrades in that respect. And I'll talk about our own project that we're doing on our own site where we've actually had to put more cabling and substations in, and it's a big part of the project. We're retaining the pipework, ancillaries, valves, insulation, all the things that's already existing in the hospital, and we're able to retain all of those because it's the same steam going down the pipe. It's just been generated from electricity, not gas. The operators already know how to use all the equipment because it's only a small proportion of the equipment that's changed in the steam generation. We've got the same end-of-use kit, the same distribution system, same valves, same ancillaries, same approach to maintenance. At the end of the process, when the steam has been used and condensed, we've got the same condensate recovery systems, heat recovery, anything that's existing, the steam itself does not change, so we can utilize the existing system. And it's the same for the feed water. RO plants, softeners, they can all stay in situ because they're all fine to be used with the electrified boiler. And in some cases, when it's appropriate, we can actually utilize the existing gas boiler. We can change it from gas to electric. And really, that's our gold standard and what we want to be approaching. Go to a system, literally change the burner for electricity, and the system will continue to operate as it did before. And we've got some solutions that do that. The Electrofit I've spoken about very briefly is our technology for electrifying an existing gas boiler. And we've got a storage solution too, called steam battery, which is a high-pressure storage tank. We're using electricity to store steam in the same way you'd use an accumulator and then distribute that when it's needed. It's capable of really high peak flows, really suitable for kind of what Chris was talking about before, and multiple sterilizers coming on at once. Is anyone familiar with the Eastwood Park Training Centre in Gloucestershire? I know there's a few people I recognise there. But if you've been there and been on training in the last 2 years, the steam you used is renewable, and it's from the world's first steam battery that they've got out the back of the facility. So this customer was looking at an electric boiler. It didn't really fit their vision, their aims in terms of decarbonising. The whole roof of their facility is solar, and they're wondering what could they do with that? How could they generate low carbon, no carbon steam using the PV they already had? So we worked with them, and we developed the first steam battery. So it's been running since August 2021. They use it to power their sterilizers. So if you've been there and done training with their steam, it's generated from a steam battery. The year after, we actually developed that one step further. We refined the technology a little bit, still in Gloucestershire, but for a heating system. So space heating, utilising one of our easy heat exchangers, and again, utilising the high heat transfer properties of steam to heat a huge system of buildings, rooms, colleges, and completely digitally connected. So a 3D scan digital twin, full remote connectivity through our sister company, Cotopaxi. And then over in Turkey, we've worked with one of our strategic accounts to actually electrify one of their boilers. So this was an existing gas boiler that we went along to, opened up, took the burner out, fitted electrical elements into the boiler, and completely converted that boiler to electricity. You can see they've actually left, the customer chose to leave the gas pipe in here. So if it didn't work or they want to switch back to gas, they can take this cabinet off, pull the elements out, put their burner back in. So there's no significant long-term modifications to this boiler, and that's how easy the switch is. And we're starting to see how we can couple our solutions with themselves, so a number of Target Zero solutions together, and even with other technologies like heat pumps and small package boilers, to bring those electrical loads on sites down. So we worked with a customer where this was their steam demand, peaks at 1.6 megawatts equivalent, so a pretty big leap from 400 to 1.6, and 4 times the load when all the sterilizers came on and everything was heating up. A real challenge for them to get that much power into their site. Very restricted, remote, difficult to run more power to their site. What we're able to do is actually split this into 2 sections, a very low-powered small package boiler, and then the steam battery charging over a long period of time and deploying short, sharp peaks into that system. We managed to reduce their electrical requirement from 1.6 megawatts to 600 kilowatts. So a megawatt reduction in the power requirement for that site. And we're walking the talk as well. At our largest manufacturing facility in Cheltenham, we've made the decision to electrify our entire steam generation, so swapping from gas to electricity. We're doing it at a high voltage, 4,160 volts, to enable us to reduce the current, which reduces our losses. We're upgrading from 2 megawatts to 9 megawatts. We've actually run all the power into the site now, a 7 megawatt increase, 2.5 kilometre cable run, which made us very unpopular with the locals. But it's the right thing to do to decarbonise our site. So we're targeting that 50% reduction in Scope 1 and Scope 2 by 2025, and 80% of our electricity will be self-generated or renewably sourced. And there's a map of Cheltenham where we've run our cable.
So just to complement what Sean has explained there, our decarbonisation solutions here are more kind of towards the latter, more mature stages of a decarbonisation journey. So at Spirax Sarco, we're able to support our customers across the entire journey, which starts with optimizing the system to eliminate waste, optimize your existing system. So this might be some more doing the basic things well, like managing your steam trap population, avoiding steam leaks, making sure you've got good insulation to avoid the unnecessary losses in the pipework. Some more advanced audit opportunities that we could find with heat recovery, you know, improving boiler efficiency, many other improvements that we can do to reduce energy efficiency. Some of the more deep dive thermal surveys that we'll do will look at the entire energy balance of a system and see if there are any opportunities to stabilize the system, remove the peaks, maybe even, yeah, so look at the demand and optimize it. And then the manage part of the journey is about connected services, connected products that we can manage and monitor our systems to make sure that we're right-sizing our solutions when it comes to going to greener tariffs and electrification. So, in the UK, we have a consultative service where we can implement that right from optimize, manage and decarbonize using our advanced consultation services. So if you would like to speak to anybody about what we've discussed today and how we've gone about our validation of our clean steam generators or our decarbonisation solutions, or even how we can help optimize your system and reduce energy losses, then you can speak to any of us and Steve and Kevin, and we're positioned at stand B3.